I apologize that I have not gotten a chance to do this any sooner in the unit. I've had a few families asking questions about the Unit 6 multiplying and division strategies, especially since we are not doing it in kind of a traditional way. It's probably not the way that mom, dad, you guys learned it growing up, and it's definitely not the way I learned it growing up. So I thought I'd put together a tutorial to kind of help your kiddo with homework at night. So I'm going to use the problem. Sorry, I gotta find where my problem went here. I'm going to use the problem 260 divided by 4 as our main division problem here. Okay, and I'm just going to show you how to solve this same problem multiple ways. So the first way that we've been talking about is through a ratio table. Okay, and honestly, this is just kind of going through the factors and multiples of the number. So if I have a ratio table to find this answer, I'm going to set it up. And we have this here is just the categories. These categories could literally be anything. We usually make them teams and kids. So for every one team, there is 4 kids. Okay. Our target, though, is this 260. So I'm going to put that all the way down here because that's our target. How many teams fit 260 kids? That's what we're solving for. So as a ratio table, we would use just our normal multiplication and think about, I know 2 times 4 is going to get me 8. So 2 groups with 4 kids each would be 8. Now, obviously, I can keep going 1, 2, 3, 4, 5, but it's going to take me a long time that way to get to 260. So I might jump around on this ratio table and think, what's going to get me closer? Well, I'm going to try 40 just because it's a nice big number. And whenever we have multiples of 10, or values of 10, we've talked about how you can cover up the 0 and then it's 4 times 4, but you have to put that 0 back on. So 4 times 4 would get me 16, and we put the 0 back on for 160. Oh, well, that's kind of close there. All right. I wonder if I were to try, let's try 60. Okay. Well, again, I'm going to cover up that 0. So I have 6 times 4. I know that's 24. And put this 0 back in. We have 240. Ooh, that's even closer. So now, if I have not gotten to my exact target on this ratio table, I can take pieces of it and add them together to get me to where I need to be. Okay, so I would look at 240 plus, which I got from here, plus 4. If I took here, that's only going to get me to 244. So that doesn't work. This is what we call guess and check, where we're just kind of putting pieces together and seeing how it goes. Okay. Well, I'm looking at this and I see these are all in the ones place. That's going to be way too big. I need something to change this tens place. So I know numbers that change my tens place would be something like 4. 4 times 4 would be 16. Well, it still puts something in the ones place there. What about times 5? 5 times 4 is 20. You know, I'm going to try adding again. I liked this 240. Maybe I try adding this 20. And that's going to get me to my target number of 260. Okay. But obviously, this is the number we already have. So where's my answer? This is where I'm going to take the upper part of the ratio table that I added together. I added the 240 and the 20. So I'm going to take the number above it, the 60 and the 5. I'm going to add those together. I get 65. That is my final answer. Okay, so I would have 65 teams, 4 kids each, with 260 total children. That's how we use ratio tables. One of the other methods we use is called an area model. And this is just using finding area to find this total answer, okay? Again, I'm going to use this same problem just to keep it consistent. Area model, we always start off by drawing a rectangle because we're finding the area. And we've already discussed the area formula is length times width, okay? So if this is my length here, I'm going to put that in a box to keep it separate, then this is my width, all right? We know our total area, the total space, is 260. So I'm going to keep that on the inside because that's what I know my whole inside space is. And I know one of my dimensions is 4. If this is 4, that means this is also 4. But we do not know the measure of this length yet. That's what we're searching for. Searching for length equals, okay? And we have talked about what variables stand for and mean as well. So we need to know blank times 4 is going to get me 260. Similar to ratio tables, we're going to do some guess and checking. So I'm going to go through and I'm going to say, I'm going to start with 50. And again, value of 10, I'm going to cover the 0. 5 times 4 is 20 and put that 0 back on. So this part of the area is worth 200. We're not quite at my target yet. I can't think of anything that multiplies to make 60 right away, but I do know 10 times 4 would be 40. So this space would equal 40. Well, if I think about putting these together, 240, I get 240. I'm not quite at that target yet. What's going to get me 20 more pieces? Well, I know 5 times 4 is 20. So now if I add another 20 here, I get to my target of 260, okay? But again, where's my final answer? Where is L equals? Well, if this whole side equals L, then we're just going to add everything here together to find that L. 50 plus 10 plus 5. And it's going to get us 65. So L equals 65. And that's area model. We can do this by being given the area. We can also do this with area model when we're finding the perimeter. For example, if we know the perimeter is 260, I'm going to draw another rectangle. If we know the total perimeter, so from here all around, as if we're building a fence, we know that perimeter is equal to 260, and we know one of our dimensions is equal to 4. Well, if this is 4, then this is 4. We need to find this missing dimension. And again, we know the perimeter formula is length plus width plus width. We've also said this as 2 times length plus 2 times width. Okay, so if I know these two sides are 4, I can add that together to get 8 total from this side and this side put together. Because remember, we're finding perimeter here. So 8 away from this 260 is going to get us the missing dimension, 252. And then we're going to divide by 2 to get us our final length. And that's how we've been solving with multiplying and dividing. Sometimes these big numbers get a little hard to divide like this. So we've talked about breaking it up into pieces, okay? We can even break it up into each of the values. So this 200, I can split that 200 in half by getting 100. That's just this 200 that I broke up. 50, I can break in half and get 25. And 2 I can break in half and get 1. Then I can add all these pieces together, 100 plus 25 plus 1, and get 126 as my final answer. So L equals 126, okay? The biggest reason I'm showing this is because we in 4th grade have not learned yet how to do problems like 35 times 68. Stacking like this, we have not learned. This they will take part of in 5th grade. We also have not learned division going like this, called long division, okay? We haven't worked on this at all. And this they won't actually work on until 6th grade. So please, to help with the process that we're working on in class, we really, really ask that you are not trying to do either of these two methods at home. It's going to create more confusion. I hope this tutorial helps. And again, if you need more explanation, I would be happy to.